Logical operators. The following logical operators can be used to produce Boolean results. The syntax meaning is as simple as we use this to symbol to designate an OR operation, and this two ampersand symbol to invoke an AND operator, and the exclamation point and the variable denotes not whatever the value of A. So that's logical operators. As to the truth table for OR and NOT, this is how it works. Suppose our value of A is true and our value of B is true, and we have a command that goes as A or B, wherein the value of our A is true and the value of our B is also true. Therefore, the result is true. Because when you say AND operator, once there is a true statement in an expression, therefore the result is also true. It should be that the true statement should be true to come up with a true result for the AND operator. So if A is true and B is true, then the result is also true. When A is true and B is false, the result for OR operation is true. But for AND operator, it is false because it should be that the true statement is true to come up with the true statement for AND operator. Here comes false or B is true. Answer is true again because so long as there is a true statement in the expression, then the result is also true. But with AND operator, you have now false because of a false statement. A single false statement in the expression would create a result of false statement in AND operator. Then for false, the result for OR is also false, and for AND is also false. So it should be that the true statement is true to come up a true answer for AND operator, and whenever there is a single true statement and expression, the result is true whenever you use OR operator. For NOT, it displays now the opposite of what the value is doing. Like if A is true and if you would release not true, then the answer is false. If A is false and you would release not false, then the answer is true. So that's the truth table for AND and NOT. So truth table for OR and NOT. Let us have a sample one of a Boolean operators. So we declare x and we initialize 3 to our variable x and 5 to our variable y. And we release now a command evaluating if x is equals to 3 and y is lesser than 10. Knowing that our value of x is 3, therefore this statement, this expression is true. And y is 5, and if 5 is lesser than 10, it's also true because 5 is lesser than 10. Therefore, this is true, and the value of this also is true. So we just simply could see it as this is true and operator true. So evaluating true and true based on our truth table, the value of m is also true. For the second expression, which is x is equals to 3, that's 3 also is our value of x. And y, we evaluate y if it's greater than 10. So this statement is another way of expressing a true statement and a false statement. False statement because y, we declare the value of our y is 5, and we evaluate if y is greater than 10, and 5 is not greater than 10, so that makes it as false. Therefore, true and false for the AND operator, it will give us a false answer. So n will be false. So let us try C. Okay, there you have now true for our m and false for our n. So that's the use of AND logical operator. Example number 3. This time we will use the NOT operator. So first we evaluate if x is equal to 3. This is true statement. So this is a true statement. But we get now, okay, we get now the reverse value of true, which is we place now not. So not true, this will give us a false statement, false result, or false value of m. And this one is x equals to 4, and our value of x is 5. So is 5 equal to 4? So obviously it's false, but we get now the not false statement because of this operator, the exclamation point that signifies not. Therefore not false, that will give us true. So the result will be false, true. So m will be false and n is true. So let us see. There you have false of our m and true for our n. Why? Because the result of this expression is true, but because of this operator, that makes it false. The result of this statement is false, as mentioned here, and because of the exclamation point, which is not, therefore it gives now the opposite of false, which is true, and that makes it as true value here. Okay, let us have another example. This is example number 4. Now in this example, we create another use of AND operator and OR operator with a bit of a complex expression. Wherein we compare the value of x if it's equal to y, and the result is then compared to another expression, which is x plus y, and compared to the value of 8. So first is, let us evaluate this expression. We have x is, the value of our x is 3 as based on this, and the value of our y is 5. So if we are going to evaluate this expression, that will give us an answer of false, because 3 is not equal to 5. So that's false. And we have another AND operator evaluating the second expression, which is 3. That's the value of our x. So x is 3 plus y, which is 5, and that will give us a value of 8. And 8 is compared now to 8. So is 8 equal to 8? So that is a true statement. So if you could see, this whole expression here gives now a value of a true result. And the way it evaluated is it performed first the operation before it's compared. So this will give us a result of false and true, since AND operator strictly it should be that the true statement is true to give you a true answer. So since there's a presence of false, then this give us a false answer or false result. For the second one, we have x is 3 again and y is 5. So is x, which is 3, equal to y, which is 5? So that is obviously a false. And evaluated it again to another expression, which is x. No, we use AND operators. So we have OR operator, sorry. So we have OR, and we have x. The value of our x is 3 plus y of 5, so that gives us 8. So we have 8 is equals to 8. So that is a true statement. So this time, since it's a false, it's an OR operator. So whenever there is a presence of true statement, that means the answer is true. So this will give us a true value of our n. So our m is false. So that's the value of our m. And our n value is true. So that's the value of the n that will be displayed. So let us see the result. Let's execute the program and see the result if it's true. So there you have, m is false. As you can see, that's a false, and t is true for our, and that's you have here a true statement. So that's example number 4. Okay, example number 5. So for this example, as you can see, there are 3 operators for evaluation, and The way the compiler will read this one is from left to right. So from left to right, evaluating first this one, followed by the comparison to the value of this, and lastly is to the comparison of the result of this one. Although this is a very bad expression, but for the purpose of how the compiler works, or how do the program evaluates the expression that's given to it. So you can see here there's note that's a dead code, because this one and the dead code is highlighting 2 lesser than 3, because it was not specified if this value will be compared to this expression, or this value will be compared to this expression. So for this kind of operation, for this kind of expression, it's good to have a proper assigning of open and close parentheses, whether you're going to perform this one, this group first, or you're going to perform a comparison of this value, right, before you perform the AND operator. But going back to the original expression, wherein it does not have any separator of the two operation to be performed first, so this way it will be evaluated from left to right. So from left to right, the starting expression is, we compare 3 if it's equal to 5, and that is a false statement because 3 is not equals to 5. And the second expression that's evaluated is 2 lesser than 3, which is, we have now the AND operator. We compared if it's equal to, if it is 2 is lesser than 3, which is true. Then the result of this is, so false and true, the result is false, because a true statement, it should be that the two condition is true to come up with the true answer or true value. Next to that is false, is then compared to the expression which is 3 greater than or equal to 0, which is compared or use now or operator, and the result of this is also true. Therefore we have false or true, and since it's a presence of true, the result is true. So for this one, the result of this is true. So we will see. There you have now, M is true. Our M is true based on this evaluation, result. Okay, but if we will put a parenthesis on what operations or what expressions should be performed first, then the result will change. For example, if we will do the comparison of this one before, it will be compared to the second expression here on the right side. Then let's see what's the result. We have is 3 equal to 5. That is a false statement, and compared now, alright, this is from left to right, so it's just like similar to what we have done. So we'll change this one. What if we will perform this time such that the result of the OR operator to be performed first before the AND operator? So we have is 2 lesser than 3, so that's a true statement. And we have OR operator, and we compared now is 3 greater than or equal to 0, so that's another true statement, and the result for this is true because of an OR operator. Now the true value is compared with is 3 equal to 5, which is false, so that's in the AND operator, and the result is false. And since there's a false statement or false value, then it gives us a false value for M. So with this kind of assigning the proper parenthesis of which expression to be evaluated first or to be performed first, so the result is false, unlike a while ago that we did not designate any parenthesis as to what will be the expression to be evaluated first. It just goes from left to right, kind of evaluating the expression. So let us see. The result is false based on our tracing. Why? Because it performed first this inside of this parenthesis based on our grouping we created before it performs now the AND operator and comparing it to the value of this expression, and which gives us a value of false value to our m variable.